again for that update. So next up on our program, we have Marshall Smith, who's going to give us an Artemis overview and talk about human lunar exploration programs. And there is a new clicker up here that should work for the future speakers.
Hey, good morning. We'll see if the new clicker works. Well, maybe I need some operational training. There we go. Got it. Big green button. Okay, so Jim just talked a little bit about where we're going, but I wanted to give a quick overview of the plan that we have. There we go. Is that better? All right. I want to give a quick overview of the plan that we have going on. I've got 15 minutes or a little bit less, so I'll go quickly. So Artemis 1 is what we used to call EM1, or Exploration Mission 1. It hasn't changed. That is our first test flight with the Orion and SLS system. That will go out to it'll actually go conduct a pretty complicated mission. We're going to go to a distant retrograde orbit, does all the activities that we would do to go to an NRHO orbit or any other type of complicated weak stability boundary orbit. So we'll go do that test. Following that, we'll have the first crewed flight test, Artemis 2, which used to be EM2. It's the same mission. We're going to do a highly elliptical orbit, a 24-hour orbit. We'll check out all the ECLIS systems, the life support systems. And then at that point, if we're good to go, and that after that first 24 hours, we'll do a burn and go do a flyby Apollo 8 style with a free return trajectory and come back to the Earth. Following that, the SLS and Orion will be ready to go to the moon for supporting our regular missions as we have planned. In the meantime, we'll also do Artemis Support Mission 1 and Artemis Support Mission 2. First, we'll put up the PPE, the Power Propulsion Element, which is the first high-powered solar electric propulsion system that'll actually provide the capability for the Gateway to keep the Gateway in the orbit that we're looking for, as well as power for the system. Followed up by the HALO, which is the first pressurized module to be delivered. That is the habitation and logistics outpost. And I'll go into more detail on those two components, so I'll save that for a minute. And then we'll be ready for the 2024 mission. At that point, we'll send up surface logistics, which will be suits, consumables, things we'll need for the mission. And then we'll send up the lander itself, which will be aggregated depending upon the proposals that we get. Some may be single systems, some may be aggregated, but they'll meet at the Gateway. The crew will come up on Artemis 3, which will arrive. Crew will exit the Orion, get into the HALO, get the consumables and the suits out, transfer them, check out the lander itself, make sure things are ready to go. 2 crew will leave and then go down to the surface, conduct EVAs and the other things that we want to go do on the surface of the moon for that first mission. Come back, crew will then board the Orion and come home at that point. In the meantime, science and technology will be in the process of being developed to support this lunar mission. We have the CLIPS program, which is the Commercial Lunar Payload Services program, which will be launching 2 to 3 times per year starting in 2020, missions to the South Pole and other parts of the moon, where we're going to learn a lot about the moon and do a lot of robotic introspection on what we're going to go do. A lot of people say it's robotic versus man. That's not true at all. We go together. There are things that we can do with robots that'll help us make the best use of the time when we have crew available and able to do things in real time. So between both of those are both powerful advantages. Also, we'll have a large-scale cargo lander in the 23 timeframe. It could be very much like the descent element that we would use on the human side of the house, but that large-scale cargo lander could develop very large scientific experiments, which is ISRU, in situ resource utilization experiments, or even rovers. So the Gateway itself, talk a little bit about that. We have the power propulsion element that's provided by Maxar. They'll be providing the power and propulsion, which is much in excess of what's typically done on a typical satellite comm system. It's based on a standard satellite system. It's not new. It's not from scratch. It is based off of a bus that has been around since the 80s and have flown quite a few missions. And then we're augmenting the power system capability as well. Following that is the HALO, which is not new. It is based on the Cygnus system. It is it's by Northrop Grumman has the RFP. It is a 4-barrel Cygnus. We've added radio ports for docking as well as an axial port on the other end. And you can see the logistics module, which would come up. That is actually a contract that's out. It's being evaluated right now. Proposals have been turned in. And then following that, you'll see the human landing system. Again, those contracts are out for proposal. Those proposals are due on November the 5th. And then the Orion and crew module will dock at the end. So this is a very minimalistic system. It's not a station. It is a spacecraft. It is capable of moving and changing orbits to help us go to the areas that we find most interesting. North Pole, South Pole. We can go to L1, L2, heliophysics. This is the beginnings of what we would see and use for going to Mars. And again, it's built around an open architecture. We've defined quite a number of standards internationally. We work with our industry and our international partners to devise interoperability standards, so that just like when you plug in a USB and you expect it to work in your computer, if you follow our docking standard, you can dock. If you follow our ECLSS standard or a life support system standard, we'll be able to share resources and capabilities. Thermal systems, communications, all of those standards are out there and are available to be used. Following Artemis 1, Artemis 1 phase 1 is really just to get us to 2024. Everything's necessary to do that. We'll get into phase 2, which is building sustainability. A lot of people talk about, oh, we're going to go to the moon and then we're leaving it and we're going to land and then we're done and we're going to Mars. It's not true. We didn't abandon LEO, low Earth orbit, when we go to the moon, and we're not going to abandon it when we go to the moon the next time. And just like that, we're not going to abandon it when we go from the moon to Mars, and then from Mars to Io or some other planet. I mean, we're going to keep going. So this is all about going and staying and living and building an economy and a capability in deep space. So we have yearly missions planned, Artemis 4, 5, 6, 7, et cetera. As we move out, we'll continue to build up capability. CLIPS will continue going. We'll continue launching CLIPS opportunities, doing science around the surface of the moon. We'll go to other parts of the moon. There's more interesting than just at the South Pole. There's more interesting than just at the North Pole. So we'll go to the other parts. We'll deploy habitats. We'll deploy rovers. We'll deploy pressurized rovers and unpressurized rovers. Again, commercial, we'll look for commercial to see what kind of markets there are for mining and other types of things that are out there as we move forward. So science and enabling science and learning about our planet and our universe that we live in by studying the moon. So in particular, Science Mission Directorate has been looking at what kind of lunar science that we can go do by the surface. You'll hear more about that in some later talks, so I won't go into a lot, but I'll just talk about, polar landers and rovers are a key part of this, being able to get direct measurements of the volatiles that we have out there, being able to explore the PSRs, permanently shadowed regions, where we believe water ice may be readily available. Also looking at not going to the poles. There's a lot going on in other places around the moon that we would like to see. The moon hasn't got a active magnetosphere. Well, isn't that either, but doesn't have an active geologic cycle. It's not overturning. So the things that are on the surface of the moon are the things that have been on the surface of the moon for billions of years, as opposed to at the Earth, where it gets turned over by the Earth's crust. So we can learn a lot about the Earth by studying the moon and different parts of the moon. So we're going to continue to explore other parts of the moon with our non-polar landers and rovers. Orbital data, we're not abandoning the orbits. We're going to continue doing orbit surveys, putting up CubeSats, particularly. Their CubeSats are going to be delivered by Artemis 1, and then in future missions that will help us gain new data, new insights into the universe. And then finally, how do we use the resources that are there? How do we use the resources to make habitats? How do we use the resources to provide fuel and air and water for our crews to live on? Those capabilities are there. And then my last slide is just to say that we've done more, and I'm not going to read this to you. We've done more in the past 6 months than we've done in 2 years because of the mission, the press to get to 2024. That is actually a very good thing, and has actually helped our culture and helped our way of thinking about how do we do things faster and better as we move forward. And with that, I think I will finish on time. So I can take some questions.
Is this one on? Or? well, geez. Okay. Hi. Thank you. I was just curious on the slide with Artemis 4 through 7 there, you had a, oh, I'm Jason. Sorry. Hi. And
Jason from
that's
where?
Clive. Zandef Dexit. That's the name of my company. Nobody can remember it, though. It's okay.
Okay.
I was just curious, what do you have any, are there any plans for specific human habitation on the moon as far as how are they going to be collected? You know, like we just saw sort of a lot of pictures of people
Right.
and things strewn about.
Yeah, so you want to know what the plan is further down beyond 2024.
Yeah, just as far as collecting people, setting up like a base of some sort, or, you know, collective habitats versus sending people sort of in different regions like we've done before, and, you know.
Right. So there's a couple of things that you got to look at. Is one thing we need to know is kind of what we're going to find. You know, there's the thought that you could go to one place and stay there, but then that kind of limits where you're going. If we keep going back to that same place, we build a fixed habitat, that might limit you. That might be the right thing to do. We need to go see what CLIPS tells us and what we learn about different parts of the moon. The other part is that we actually really invest in mobility. So in other words, pressurized rovers could serve as short-term stays, for example, those types of things. So those are options out there if we want to go mobile. We may want to do both. And of course, this is going to build up over time. Since we're going to stay and we're looking for international partners to engage with us as well, we're looking for people to provide habitats and rovers and those types of things. I think that gives us lots of options so we can then move around. And so we are thinking about what that looks like and what that long-term stability plan looks like. And we promised to Congress and others that we're going to have a plan as we move forward as to what that would look like in the future.
Okay, yeah, I guess maybe to follow up with what you just said is like there's a lot of science that'll be done between now and 2024, specifically in terms of finding resources. And is there any plan or thought to maybe amending that between now and then or it's still pretty much when we get to 2024, it's still going to be like, all right, see where we're at.
We obviously have to make a plan before 2024 because then 25 is going to be here and we're going to say, what are we doing? Right. So we're actually working on that right now. We want to see, and we're kind of going down multiple paths because then we can see what best fits based on the science early science we get back as to where we're going to go.
Thank you.
David Kring, LPI. During Constellation, there was a trade study between unpressurized and small pressurized rovers, and the productivity of small pressurized rovers just is huge. Right. And so I'm glad that you've mentioned that twice. So when do you envision that type of asset being deployed to the surface? Are you going to wait until 2028 when crew can utilize it, or will you consider telerobotic operations before crew arrival? And I guess a part two to that, are you thinking of a single rover for 2 crew on the surface, or when, or do you envision putting 4 crew on the surface?
Okay, so we have 2 requirements, for example, in our HLS BA that's out. One is a 2024 requirement. It's really the first time, and we're allowing only 2. If you wanted to do 2, our sustainability requirement is 4. You know, somebody can deliver 4 right off the bat, great. But that's our first requirement is at least 2, and then eventually grow into 4 by 2020. Well, by the next mission. So that's the requirement. So we want to get up to 4 pretty quick. Obviously, we're going to factor in that pre-placed capability, those types of things. Rovers like you're pulling on, we would like to see the CLIPS missions, for example, put up rovers or allow telerobotic capability as we go and look. We can actually use that to hone in on where do we want to go when we have crew there for that short time that we're there. We want to make sure that we're using the best skills that we have. And what was the other part of that question? Did I get everything?
Well, if you build SPRs, are you going to deploy them before the crew of 4 get there in 2028?
Yeah, right. So that's part of what we're looking at as far as the deployments and what we're going to actually send up at each before 2024. And then, of course, by 2028, you know, when do we get those pressurized rovers up there? It'll probably be in the 28 to 30 timeframe. That's kind of what we're thinking.
Okay, thank you.
Hi, Marshall. John Gruner from Johnson Space Center. I really like the approach we're taking with Artemis and buying services to get to the moon. I'm wondering if this is going to be extended to the surface of the moon, where we buy power by the kilowatt, we buy communications by the gigabit, we rent a room, we rent a car, or is it going to be government-operated, government-owned things on the surface?
So just like we've gone to commercial cargo, where we're buying services for cargo and LEO, we're going to commercial crew for crew services in LEO. We're talking about in the proposal, if you go read it, it specifically says, eventually we're going to go to what we call a landed services contract, where we're talking about landing, crew, and services following the BAA, which is just for early mission demonstration. I expect you would see similar trends as we move forward. If you think about it, those are the trends we keep doing. And so, if we're talking about buying power, buying data, buying fuel, buying, consumables, those types of things, you may see something like that in the future.
Kirby Runyon, Johns Hopkins APL. I was really encouraged to hear that you feel you've made more progress in the last 6 months than the previous 2 years. I know that there's been a lot of congressional skepticism that there's a need to accelerate the return to the moon from 2028 to 2024. And I'd just like to make a plug for educating certain members of Congress, especially in this House Oversight Committee and Appropriations Committee, on the improved morale and the improved culture and the benefits of going fast rather than kind of business as usual slow.
Yep.
So just more of a comment, really. Thank
Okay, no question, but I like your comment. All right.
I'm going to use the chair's prerogative to ask the last question. So you commented a lot on Artemis. Since there's a lot of scientists in the room, can you comment on what opportunities for science instrumentation on Artemis specifically, and not so much CLIPS, might be available in the future, and what programs will help develop those instruments?
Yeah, so we expect that Artemis will be key in providing science opportunities and capability. I don't know what exactly those will be. We've got to get our proposals in for the landers, but we're going to be launching multiple times a year to the moon. So there's opportunities, if there's payload capability there and payload mass available, that we could support that with additional secondaries and CubeSats and other things like that. Also on the Artemis themselves, depending upon the proposals and the missions, there may be opportunities for science to, again, ride along on that. And of course, obviously one of the major goals is to conduct science with crew on the surface to learn about our environment and our universe. So all of those things are key factors as we move forward. So science is a major player in this, which is, again, the purpose of what most of y'all are here for. And you'll hear more about that, other speakers today. I just wanted to give you the big picture of what we're doing from a perspective. Okay, I think that's all. All right, thanks.